So yeah, as we're doing all of these, if you're noticing, they're all having an x squared, which means when we're at the end and we're done, we're ending up with two different answers. And we saw that the first time with the x squared minus 1, or sorry, x squared minus 9, which was x plus 3, x minus 3. Yeah. Are we okay here? So then 2x squared minus 14, 2x squared equals 14, x squared equals 7. And then the last step is to get rid of the square root. It's square root of something squared, which means it'll be x equals plus or minus 7. Whenever there's that squared and we're taking the square root, there's two answers. So if you're looking at what you wrote and you're like, oh, we only wrote square root of 7, should be plus or minus square root of 7. Next one up. Are you ready now? 2x squared plus 14 equals 0. After you take the square root of both sides, you'll have x equals plus or minus the square root of negative 7. Negative 7. And then at that point, you have two options. One option, again, you got to get to this place first. You could get to this place and say there are no real solutions because you cannot take the square root of a negative number. Or you can split it up underneath the square root. So if I have another marker here, if I do this, square root of negative 7, that's what we had, right? This should be negative. Square root of negative 7 gets split. The square root of negative 1 and the square root of 7. Because the square root of negative 1 is the imaginary number I. This stays this, so instead of x equals, so it wouldn't be I like that, it would be x equals plus or minus I square root of 7. Once that negative comes out of the square root, it's a number. We call it the number I, the imaginary number I, which is an actual value, but it's not a real number. So now, at this point, we've gone for about 10 minutes or so of actual work. I'm going to pause. If you need to go, as someone's already doing, and write down yourself some notes to your future forgetful self so you don't forget what we just did here, go do that now. Take a sip of water, then come back and erase your boards. We'll do the next one. That will give you two different answers, not just like plus or minus 3. So the equation is, in parentheses, 2x minus 5. And the parenthesis set is squared, equals 16. So it's 2x minus 5 in parentheses, squared, equals 16. What I don't want you to do is don't FOIL that out. do similar to what we've done in the past with this next step. Talk with your group, see if you can figure out where to go. Yeah. There would definitely be two answers and two different answers. For those of you that are like graphically minded, a squared function means it's a parabola. And the parabola is crossing the x-axis at two different places. That's why there's two answers.
I'm something minded, but I'm definitely.
I'm not saying that you won't use plus or minus at some point. I said your final answer, like I think some people got 9/2. Is that right? Was that your answer to one of them? All right, it's not plus or minus 9/2. You could FOIL it out, but it would be a much bigger process.
We beat everybody.
Want a cookie?
Oh. You might want to consult with the 8s if you want to know how to do it. If you're like, no, I think we're almost there. And then see if they can explain it to you.
We beat Sam.
So when you take the square root of something squared, it's plus or minus, which then I make as two separate equations. So I'm going to bring that down here. I have 2x minus 5 equals 4. I have 2x minus 5 equaling negative 4. Because 4 times 4 is 16. Negative 4 times negative 4 is 16. And then I do algebra. Add 5 to both sides. 2x equals 9. Here I add 5 to both sides. 2x equals positive 1. Then divide by 2. X is 9/2. Here I have x is 1/2. Next one, moving along. Your equation will be 2x minus 5 in parentheses squared equals 50. So 2x minus 5 squared equals 50. So what happens when you square root both sides? What happens when you square root something squared? You will get plus or minus the square root of 50. So you'll end up with then two equations. 2x minus 5 equals the square root of 50. And your other equation was 2x minus 5 equals the negative square root of 50. The hard part with looking at a final solution is then not seeing what the steps and how they happened and in order for how you get to the two different answers. Yep. All right, if you need to take about a minute, 60 to 90 seconds, go write some things down. And then when you've written down what you need to write down, back to the boards for the next set of problems. Actually, for time's sake, we'll just do them together. That's just my handwriting. So I take that back. You're knocking me back at the boards. I looked at the time, so we'll do so we can get through everything today up on the boards. So as people get going and start studying is always this, when people say, oh, I studied so hard, and my usual question is how did you study? What did that actually look like? Working problems, reworking problems, and then working them again is better than reading anything. To really maximize your studying in solving by factoring, are there two numbers that multiply to 16 that add to 8? Positive 4 and positive 4 both multiply to 16. They add to 8. So that's how I'd factor it. And then like we've been doing, I have two things that multiply to be 0, which means one of them must be 0. I can actually write a separate little equation, x plus 4 equals 0, subtract 4, x equals negative 4. And since they're identical, I don't have to do it a second time. I mean, I could, but I'd have x plus 4. It would also be negative 4. So this is a case where there is only one answer. So actually, we said when we did this, when we had x squareds, when I have an equation that's an x squared, there could be two answers, which were a lot of the problems that we've already done today. There could be 0 real answers. That's where I had this, that would be a case where I have the, square root of negative 4 or something like that. Where I have a square root of a negative number. There's going to be no real answers. And then I could have one answer. And that's like this case over here. And the one answer really is the fact that the answer of negative 4 happens twice. This one's negative 4 and this one's negative 4. But since negative 4 is the same as negative 4, there's only one real answer. Graphically, again, if you think graphically, this is a parabola. And at negative 4, 1, 2, 3, 4, negative 4 on my x-axis. When x is negative 4, my parabola will touch at the axis. That's it. There's one solution. We call it one root, 1, 0, something like that. When we had equations where there were two answers, it would be like having a parabola like this. Oh, it crossed right there and right there. There were two answers. When there's no real answers, that would be like a parabola that doesn't ever touch the x-axis, like that yellow one or that yellow one. They never touch the x-axis, so there are no real zeros. So that's what's going on graphically. But if we go to the next one here, my leading coefficient is 1, so I'm like, oh, great. I can look and say, are there two numbers that multiply to 20 and add to 12? So numbers that multiply to 20, 4 times 5. 4 times 5 is 20, but 4 plus 5 is 9. 2 and 10. I just write the 2 and 10 there just as a refresher. They're multiplying to a positive 20, which means they're both positive or both negative. They add to a positive 12. So this tells me that they're the same sign. This plus does. This tells me that they're both positive. If this were a plus and this was a negative, there'd be negative 2 and negative 10. If the last number is negative, that means one of them is positive, one of them is negative. And that'll be plus and plus. And then I say I got two numbers that multiply to 0, which means one of them must be 0. So x plus 2 is equal to 0. X plus 10 is equal to 0. Subtract 2. X is negative 2. Subtract 10. X is negative 10. So if I was thinking about a graph, 1, 2, there's negative 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. Since the first number is positive, that means it goes in the positive direction most of the time. It would be a graph that would look something like this. And we go back up. In algebra, that was the y-intercept. It's still the y-intercept. Like this would be all the way up here at 20. That intercept right there would be 20. So if you're wondering, how does this all go together? Graphing, back when we did like linear equations, but now we're doing parabolas. That's how these values all connect together. But algebraically, we're finding the two zeros. Negative 2 and negative 10. And then we say, well, what if we can't factor? Because we can't factor these. We can try completing the square, which we've done. Take a times c. In this first one, a times c, my a is 1. My c is negative 4. That multiplies to negative 4. Are there two numbers that multiply to negative 4 that add to positive 2? Well, you can start thinking through all the numbers that multiply to negative 4. 1 times negative 4. Negative 1 times positive 4. But the thing is, though, these add to negative 3. These here add to positive 3. I could do 2 and negative 2, but they add to 0. So then what do? Can't complete the square. Then I'm going to use the binomial formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And what I do there now is I go to this equation on the left and I look at what is my a value. My a value here is the number in front of the x squared. It's the number 1. The b value is the number in front of the x, and for me, that's the positive number 2. And the c value is the number that's the last number. And for me, in this equation, that's -4. And then I'm going to start plugging it in to that equation. X equals negative, and the b value over here was 2. So it'll be -2, plus or minus the square root of. The b was 2, so b squared is 4. 2 times 2. Minus 4 times a is 1, times c is -4. Again, those are just up here. There's the a, there's the c. It's off the screen a bit there, but. And then this is all over 2 times 1. When doing the quadratic formula, not binomial formula, the quadratic formula, my apologies on that. Binomial formula is something you'll see in stats. We were just talking about that the other day, which is why my head was thinking statistics. The quadratic formula, do not skip steps. Take a lot of space to simplify this. So I'm going to have x equals -2 plus or minus the square root of 4. And then I'm going to go, okay, minus 4 times 1. 4 times 1 is 4. 4 times -4 is -16. So it's going to be -16. All over 2 times 1. Well, 2 times 1 is 2. The minute I see minus and negative, remembering back to all those arithmetic days, minus and negative is the same as plus a positive. So then what I have is x equals -2 plus or minus the square root of 20 all over 2. Because 4 plus 16 is 20. Square root of 20. Is there a number that goes into 20 that I know the square root of? And this is where if you don't have them just off the top of your head, write them down on the side of the page somewhere as you're working. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. That gets you all the way through 15 squared. But in this case, I have 20. And I know that the number 4 goes into 20. And I know the square root of 4 is 2. The other stem coming off there is now the square root of 5. 5 is prime. Nothing goes into 5 that I know the square root of evenly. It stays right there. And we move everything up. Ooh, let's move that up. X equals -2 plus or minus 2 square root of 5 all over 2. I have terms. Terms are things that are added and subtracted in the numerator. So if I can reduce, everything must have something in common. Is this divisible by 2? Yes. Is this divisible by 2? Yes. Is this divisible by 2? Yes. So here, I can reduce this 2 with this 2 and that 2, leaving me with, and I got to be careful, -2 divided by 2 is -1. It just doesn't go away, plus or minus the square root of 5. Those are my 2 real roots. Now, if you used a calculator and found out what the square root of 5 was, you go -1 plus that value. You could put that on a graph. -1 minus that value, you could put that on a graph, and you'd see those would be the 2 places that equation would cross the x-axis. So there it all is together. Sorry about that little white strip in there, just some formatting issues with my document. But so then, what if it looks more like this? The first thing I'm going to try is I'm going to try completing the square, because that's easier for factoring. I usually will make fewer mistakes. So I'm going to go a times c. So that's 3 times 8, and that's 24. I'm looking for two numbers. The 3 is positive, the 8 is positive, so this is positive. I'm going to look for two numbers that multiply to 24 and add to negative 9. Well, if they add to negative 9, they have to be both negative. So negative 3 and negative 8 will multiply to negative or positive 24. But negative 3 and negative 8 add to negative 11. That's not going to help me. Let's see. Negative 2 and negative 12 multiply to positive 24. They add to negative 14. I'm actually getting further apart. Negative 6 and negative 4 multiply to positive 24. They add to negative 10. And then I'm done. I don't have anything else that I could use. So this cannot be factored by grouping. So then I'd go to the quadratic formula. Every time you use it, write it down. So on the one sheet of paper that you can bring in for your exam again, on the front side only, you can have anything written. Might not be a bad idea to have this written down on that formula card so that you remember it if you have to use it. Then I'm going to plug in numbers, negative b. So I'm looking at this, a, b, and c. If I need to, I'll write down my a is 3, my b is negative 9, my c is positive 8. So if I have negative b and it's a negative 9, well, negative means I just have positive 9. Plus or minus the square root of negative 9 squared. Negative 9 is the b. It's 81. Minus 4 times a, which is 3, times c, which is 8. All over 2 times a, and a was 3. 9 plus or minus the square root of 81 minus, and now here's where many of you might go to your calculator. 4 times 3 is 12. 12 times 8 is 96. So it'll be minus 96. All over 2 times 3, which is 6. 9 plus or minus the square root of, and what's 81 minus 96? Negative, what? 15. All over 6. Square root of a negative number. No real solutions. 15. I'm not going to worry about simplified radical form. Again, if you're planning to take pre-calc next semester and you want to try to work that out, you can. If you get to this place right here and just leave it like this and then say no real solutions, we're solid. I'm good. If you're taking pre-calc next semester, I would recommend you try to do something with this. And if you're wrong, don't worry about it. But if you want to know what the actual final answer is, it would be x equals 9 plus I root 15 over 6. And then x equals 9 minus I root 15 all over 6. The 15 can't be simplified because, again, 1, 4, 9, 16, all my squares, nothing goes into 15. And that would be a final answer. More practical application now. If you invest things and it grows, initial investment is $2,000, investing grows to $24.20 after 2 years. This is my principal. This is my final amount. 2 years is my time. So I'd be looking saying, well, A is 24.20 equals 2,000 1 plus r. The question asks, can you find the interest rate? Well, that's r. My time was t, and that's squared. So here we go, solving for r. R is inside the parentheses, so I got to get rid of the parentheses first. Before I can do that, I got to get rid of the squared, but before I can do that, I got to get rid of the 2,000. Much like Shrek and onions, you start with the inside and say, that's where I want to get to, so I got to start with the very outer layers and get rid of the outer layers first. Divide by 2,000. Oh, there's not too many, there we go. Over 2,000 equals 1 plus r squared. I just divided both sides by 2,000. And I don't know what that number is because I don't have my calculator on me. But then, need to get rid of the square root. I will have plus or minus the square root of, let's see, I know I can do this for reducing. The zeros reduce, they're both divisible by 2, so 121 over 100. Again, you can probably, at this point, you're just doing it in a calculator, equals 1 plus r. And then the last thing is I would put this in my calculator, then subtract 1. And that will tell me what my rate is. Since it's growing, I'll get two numbers here for an answer. Whichever one is the positive number will be my rate. You finish that out and you find that the R is 0.1. So that meant it was a 10% growth rate. To go from decimals to percent, remember it's moving the decimal 2 places, so my R is 10%. If anybody says you can get 10% investment, take it. It's a very high investment rate. Atypical, but good. You're going to see a problem similar to this on the exam as well. More practical application. Object is thrown upward with a velocity of 32 feet per second from the top of a 200-foot cliff. The height of the object after t seconds is modeled by this equation. All right. If anybody in here takes a physics class, you'll see problems like this as well. The question asks, how long after the object is thrown will it strike the ground? So this is my height function. And t is my time. So you have to remember, well, what does it mean when something hits the ground? What is the height when it hits the ground? 0. So I'm going to have 0 for height equals negative 16t plus 32t plus 200. So now I have it's t squared. I have a quadratic. It's set equal to 0. It would be lovely if I could factor this thing. So the first thing I'm going to look at is to say, can I divide all of them by 16? All right. How about we do this instead? Since it's a negative, I don't like having negatives in the first. I'm going to see if I can divide everything here by negative 16. So 0 equals negative 16. So I'm factoring it out. I'm finding the GCF, greatest common factor. Here, negative 16 over negative 16 leaves me with t squared. 32 divided by negative 16 is negative 2. So I'll change that to a negative 2. T. Positive 200 divided by negative 16 is negative 12.5. Not super easy because now we can't really factor because there's a decimal. However, my A is 1. My B is negative 2. My C is negative 12.5. And then I would use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. With your calculator, you would find two different answers. One of them is positive, one of them is negative. Which is my answer? The positive one, because it asks how long. So we only can, well, time really can't be negative because you can't go back in time. So it would be the positive answer. Yeah, you can do all things through Christ, but you can't time travel. All right? This is jumping us back. A quick review. I think we covered this end of chapter 7. Solving for something like this. When we have a square root, I need to, first step is I need to get the square root. So that's the word root. Square root alone. I want the square root alone. So in this case, I'm going to add 6 to both sides of the equal sign. I'll have x minus the square root of x equals 6. Then I'm going to subtract x from both sides. I'll have negative root x equals 6 minus x. Need to get rid of the negative, which means the other two just switch signs. Multiply by a negative, so then 6 is now negative 6. Negative x is now positive x. Once I get it here, now I have done my first step. Then I will square the root, because that's how I get rid of the square root. Square that, square this. Square root of x squared is x equals. Square the right side, x squared minus 12x plus 36. We talked about this last week, or last time we met. Squaring, remember, means times itself. And then you have to FOIL, which I did very quickly in my head because I've done this for like a bazillion years. Probably as many years as your parents have been alive, I've been doing this. I know, I am that old. You might think your parents are old, but remember, I did this. I was doing Algebra 2 in 6th grade. Yeah, I know. I was that kid. I'm sorry. You all probably hated me for academics. All right, now I have a quadratic. I need to set it equal to 0. So I'm going to subtract x from both sides. Move all that up. I now have 0 equals x squared minus 13x plus 36. Even though I wrote this here, that doesn't mean those can combine. That's an x squared, that's an x. So the x has to go with that x. So if you get confused with that, then make sure you keep it lined up. Keeping your x's lined up with your x's. And now we're looking for two numbers, if I could, that will multiply to 36 and add to negative 13. If there's not, then you're going to use the quadratic formula. Honestly, even if there is, you could do the quadratic formula. If you're like, I just want to do that every time because I know it's going to give me an answer every time, go for it. The challenge is keeping track of your positives and negatives. So I leave that to you to try to finish, because we're going to go to the next one. Just as a quick reminder and refresher on these kind of things, that's where we're going here. Step 1, we need to get the square root all by itself, which means I'm going to add 5 to both sides. Either keep writing your equal sign. Sometimes I just throw a line down there to remind me that I'm doing it on both sides of that equation. Or if you're thinking about a scale, right? Got your little pan on this side, your little pan on that side. Whatever you do to one side of the scale, you have to do the other side of the scale. Otherwise, they're not equal. These are equal. So then I'll have x minus root x plus 1 equals 5. Subtract x from both sides. I'll have negative root x plus 1 equals x minus, other way around. 5 minus x. I subtracted x from both sides. Then I'm going to make everything negative. So that's now a positive. On the right-hand side, make everything a negative. The x is now positive. The 5 is now negative. I've now isolated the root all by itself. And again, because this is anything times itself, oh, that's minus, x minus 5, x minus 5. FOIL, x squared, and then minus 5x, another minus 5x, that's the minus 10x, and then plus 25. Now I have a quadratic. In order to solve a quadratic, I need to set it equal to 0. I will subtract x and subtract a 1, that's an x, and a 1 from both sides. Minus an x and minus a 1. I now have 0 equals x squared minus 11x plus 24. Do I know two numbers that multiply to 24 and add to 11? 8 and 3, but I got to make sure it's negative 8 and negative 3. Because they have to multiply to a positive 24. Now I've got two things that multiply to 0, which means one of them must be 0. Set up my two little equations there, or just recognize that x equals 8 and x equals 3 are my two answers. To that original equation up there of what makes this true. You can go back and put this in and check. 8 plus 1, that's 9. Square root of 9 is 3. X is 8. 8 minus 3 is 5. 5 minus 5 is 0. Yay, it works. You could try 3 in there. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is 1, minus 5 is, oh, that's not 0. So what happened there? 3 plus 1 is 4. Square root of 4 is 2 or negative 2. So if I had 3 minus negative 2, that's 5. 5 minus 5 is 0. Don't let the fourth can get you all worried. This is something squared. It's p squared. P squared squared is p to the fourth. This is a middle p squared, so it's kind of like it's x squared minus 3x minus 4. Two numbers that multiply to negative 4 and add to negative 3. Negative 4 and positive 1. P squared minus 4 is the difference of squares. That's where we started class today. P plus 2. P minus 2. And then this just stays as p squared plus 1. I have three things that multiply to 0, which means one of them must be 0. P is negative 2. Makes this first one 0. Negative 2 plus 2. What makes this 0? 2. And then if you wanted to, we could go p squared plus 1 equals 0. Subtract 1. P squared equals negative 1. Take the square root. P equals plus or minus the square root of negative 1, which is not a real solution. What I want you to do is write this one down. in addition to the check your understanding problems that you have, you're going to do this problem. This is actually, I think this was on the first exam, and not many people got it right. So we will start our next class by going through this and the solution that you attempt to do. Again, in addition to all the check your understanding problems you're doing in preparation for the exam, a week from today. Thank you.